technologies and let each one of you identify what technologies you think might go well with the technologies that you know well to pair up and work well together. So if you want to maybe get into that.
Sure. Yeah, I mean, there's so many really nice combinations of technologies that pair nicely with, in situ bioremediation or in situ chemical oxidation or in situ sorption. A combination that amongst those I see pretty frequently is either sort of a treatment train approach where we maybe see some chemical oxidation happening sort of on the front end of things, and then transition to a bioremediation or sorption approach once we've seen some really nice, good bulk mass reduction, and then transition to something that's going to be potentially a little bit less aggressive, but sort of a longer term solution, And as I presented on earlier, we get involved in a lot of really interesting projects where there's an in situ thermal component, often sort of on the source area, and then we come out and do an in situ treatment, either subsequently to that or sort of farther down gradient of that to capture the residuals of the plume, or hopefully it doesn't happen because folks like Lauren do a good job, but if there's any slight mobilization of the things at that source area from the thermal treatment, that can then be potentially captured by some sort of in situ installed permeable barrier or something like that. Those are the things that I see pretty frequently.
I can't think of a single project that I've worked on or that my company has worked on that hasn't had some type of combined strategy, whether thermals being implemented as the last treatment that occurs at the site with groundwater pump and treat that has happened, or enhanced bio that's shrunk the plume, and then they go and they get the funding for the source area, the stuff that's just way too residual, that has too many back diffusion issues. Yeah, I can't even think of we've done thermal upgradient to a PRB wall where the PRB wall just wasn't effective, and so the goal, the concentration goal for what it could be effective, given how it was installed, was then revised with time. And so the goal became all right, let's do thermal to reduce the concentrations that are coming off of this source to a level that would make the PRB wall effective. So we've got lots of different pairings that I've seen over the industry. I'm not sure that I would say oh, that's the best combined strategy. Every site's a little bit unique and people have their preferences. We've done ISCO and thermal. Yeah. Sorry, I'm not being more specific, but every site has a combination approach. There's no one right answer. Yeah.
So yesterday we went all metaphorical in response to this. I do like Paul's. Paul and I have different metaphors. I didn't realize that, but we do. I do like Paul's. He talks about the different technology you use to remove snow. But I'm going to fall back on mine, which is because it's about a journey, right? And you need to know where you're starting and where you want to finish, and then you got to figure out what kind of journey you're going to go on. And so if you think about you're going to a mailbox, you're just going to go out your front door, you're going to walk to a mailbox. It's a very simple mode of transportation. It's a very simple journey. It's easy to accomplish. If you're going to go to Tibet or something like that, you're going to go out, you're going to get to your car, you're going to drive your car, you're going to get to an airport, you're going to probably take some sort of conveyor system at the airport. You might even get on a little train at the airport, then you're going to get on a plane, you're going to fly someplace, usually a hub, and it just gets very complicated because it's a more complicated journey. So I actually like remediation technologies. There are all these different tools in the toolbox that can be used. You can use them spatially, like source area, plume, PRB. You can use them sequentially, where it's just you go thermal to take care of, 50,000 milligrams per kilogram or something, to bring it down to something more reasonable, where they hit their diminishing returns might be the sweet spot for ISCO. So, but they're all tools that can be used and combined. But in terms of the thing, just to actually answer your question, bio goes with just about everything. Bio is almost always going on if you're looking for it, whether you're doing ISCO or thermal, it's going on, and you can choose to stimulate it or not. But there is a level of bio going on, always.
Pairs nicely with others.
It just plays nice, it's just hanging in the background, I'm just, microbes doing their thing.
Yeah.
As often is the case, most sites that we manage, the monitor natural attenuation is the extended plume remedy, and there's, to that end is, bioremediation, I'm sure is occurring in there as well as abiotic and just, dispersion and
Totally.
other. So to flip that around, based on your, and it may not work here, but based on your earlier comment about inverting it.
I knew that would get me into trouble.
So inverting, what wouldn't work and how would that drive your remedy decision?
You're looking at me, so I'm gonna go first. So what doesn't work? There are a few compounds that, it's not gonna work with, but generally speaking, what doesn't work is a bad application. It's one of those things, and I know, again, I don't want to just be too much for the technologist, but if you can get it to work in the lab, why won't it work in the field? And it's usually you're not able to establish contact. Now, I will absolutely 100% admit sometimes you can look at it and just like, oh, wow, yeah, you're not establishing contact. It's just, just some weird fractured bedrock that you can't figure out how to connect to that fracture or something like that. I helped out a site in Texas. They were able to, and they just annihilated half the fractures. For the life of them, could not figure out how to connect to the other fractures. They had monitoring wells there, right? Because they knew it. But other than injecting into the monitoring well, they went out there and had injection fractures, injection wells in several locations. And, they had to stay a certain radius away and they couldn't connect, and so, yeah, they weren't able to establish contact. So with ISCO, and again, I still think it applies to a lot of technologies. If you can't establish contact, it's not going to be effective. Application methods, injection events, preferential flow paths, or people that inject a very small volume and expect it to treat a very large radius. Failure, failure, failure. I've had sites, and we talk about characterization. I've had sites where, people were like, this is my pilot test area, here are my wells, groundwater is going this way, and they inject and they're like, none of my wells went down, and I went through and looked at the conductivity signature. And I'm like, because all of your reagents went that way, maybe you should check your arrow of where you think your groundwater is going, because it didn't go northwest, it went south. And where it went, it treated. So, those are where it doesn't work. It's just like if you can't establish contact, people don't inject it or apply it correctly, that's where it's not going to work.
Definitely would echo everything Francis said, and the groundwater flow direction. And, Paul talked about it before too in his presentation on PRV. It comes up annoyingly frequently, right? That we are looking sort of too zoomed out, and we see like clearly there's regional groundwater flow direction that is generally the regional groundwater flow direction is very well understood. The local groundwater flow direction, not so much always. And that sometimes bites us, particularly if we're doing, like exactly like Paul said, there's a lot more forgiveness the sort of larger the treatment area is. When we're doing some demonstration testing over like a 30-foot long transect, things being a few degrees off can be really troublesome. One other thing I'd say, a lot of things definitely do play nice with each other. The ISCO to bio is sort of like a really great combination. But certainly there's been sites that I've been involved in where somebody comes to me after like a permanganate injection that seemed to work pretty well, but then is looking to transition to bio perhaps. And permanganate is, going to be pretty long lasting. And that transition to a reductive mechanism is going to be more challenging if we're still in this oxidative state. So it's not necessarily that combination can't work, but we have to time it appropriately so that we're not just, destroying the oxidant that we paid all this good money to inject and apply with hopefully some degree of precision, and then go and just do something that's gonna make it itself less effective, and then whatever we're transitioning to also less effective.
With regard to, I don't know, frustrating site conditions for thermal applications, I think of like high temperature thermal applications, and something as simple as just a tiny bit of incursion of water will mess you up so quickly. The generation, like if you have steam that's being introduced into a cell that's, getting to 400 degrees Celsius, steam actually cools it, and it happens so quickly. It just ruins everything. All the progress you made over, weeks can just disappear with a little trickle of water. So I can think of like some high temperature vadozone applications where we just scrambled looking for like, and it's always a surprise, some unknown, roof drain, or, that project in California, Beale Air Force Base, atmospheric river conditions. This operated before I even knew what an atmospheric river was. Like, when did that become a thing? A couple of years ago, we started talking about these rivers that come down from the sky, and even in California. So we had like surface water just trickling in, and it caused a lot of drama. But yeah, I don't know. It also, sometimes it's rough, like watching competitors, I don't know if it's like a vapor recovery issue, or there was this one vendor who did a project in Sweden, and it was another high temperature project that they very publicly struggled. All the data was like pushed to the public on the website, and like every day you'd log in to like see like, please let them get above the boiling point of water, and they still like weren't there. And like, I don't think there'll ever be a high temperature thermal project in Sweden again as a result. Sometimes you get these people will just have a bad experience and then never want to do it again. And so it kind of ruins things for all. I have no idea if that answered your question, Drew.
And I can relate to, on the thermal side, we have a project in New Hampshire where thermal was applied, steam, and it was a real challenge to get it up to temperature. They had numerous boiler issues. They had to bring in a bigger boiler, and then they had cooling tower issues. But ultimately, there was areas of the plume that they couldn't get the temperature. And so they had to modify to accommodate for that. And in the end, what ended up they found was that it pushed a whole lot of DNAPL up against the cheap power wall that they had to deal with later. But
Yeah, so how does that make you feel about?
This is a therapy.
Yeah.
But it leaves you with like a bad taste in your mouth about it, right? It affects like everyone's opinion about that technology.
yeah, and it's still kind of recovering and looking for other technology. Well, this is hitting all at this point for impacted levels of water. So that kind of leads to the next topic in implementation logistics in terms of applying the technology and sequentially moving to another technology. Would there be a sequence you would recommend, or lessons learned where things haven't gone as you expected?
I mean, I think the main sort of thing to consider is not there's no sort of like one way to skin any cat, right? So like, I don't know that there's a definitive prescribed sequence that always makes the most sense, but to like, just going back, definition of insanity, right? Like not just like continuing to do the same thing over and over again and expecting something different to happen. So not necessarily, it's not prescribing any specific sequence of events that makes the most sense across the board, but just being open to pivoting when it makes sense. And taking in the new information and actually assessing it, and not just like having a bias that, we're just gonna keep chugging along.
those conceptual models like never stop changing, right?
Right. We're always learning.
Yeah, you gotta be open to accepting what the data is telling you that day. Yeah, just to add to it, you know, there's from like the thermal perspective, there's some residual heat that's left behind. So like harnessing that heat and using it to your advantage with like a bio remedy. You might do bio after a thermal project and like harvest that heat and help kind of speed things up. That could be like a good sequential operation, but we've seen it all. There's also just in like the boreholes that we're putting into the ground, some of the monitoring infrastructure, we've got the ability to like incorporate injection as part of the nesting of a borehole. So we could always plan for like the future of like what's going to happen with, I don't know, maybe the goal is 99%, you know, getting 10,000 milligrams per kilogram down or 1,000 milligrams per kilogram down, and got a 99% removal and then do something else on the back end. That could be one way that you sequentially plan it out. You've got that one slide that's dedicated to how to be thoughtful about everything, right? Which I need, by the way.
Yeah.
Can share that.
Universal law of remediation right there, thoughtful of everything. Could you repeat the question? They went a slightly different direction than I was thinking I was gonna go.
Yeah, it was really just implementation logistics and, you know, different technologies that may line up, make sense for a site.
Okay, so, and the logistics is what got me going in the direction, and I'm still gonna answer because it's actually important, but it is a little different. Talking about logistics, so I'm giving a webinar next week on health and safety. And the reason for it though is that there has been a recent wave of things that are a little bit concerning, and it does involve some implementation, it does involve some logistics. And, you know, the first couple of slides, I'm just gonna be talking about something about implementation, things that, and just the logistics that's so simple, but people are just doing very odd things. And that's something as simple as how to store these reagents. These are reactive reagents that will go into the ground and do a lot of things. They are thermodynamically powerful, and people are storing them underneath trees and hurricanes. And it's led to some, you know, incidences. Nothing bad has happened, but, you know, it's one of those things where, you know, we do get feedback and people do ask us, the whole hurricane, it was even a reductive technology, which, you know, isn't as thermodynamically powerful as ISCO, but you still get it super wet. And, you know, you add water, you know, just add water to these kind of chemistries and they start to react. And sure enough, it kind of ate through the packaging, you know, and they left it out for a couple months after tropical storms, you know, went through that potential region. Closure CR, it's a safety measure. We actually have a little black thing, and it's a pressure relief valve because Closure CR has permeox in it. It's a safety measure. But guess what? If you let standing water be on top of that for an extended period of time, it will eventually migrate and then it will cause the reaction. And we're sitting here debating is like, is the safety measure actually causing a problem? You know, but if it was stored properly, no. If it was stored out over the rain, no, it wouldn't be. And then like for sulfates, some of the classics with improper storages, I mean, for sulfates and a lot of these reagents, they're salts. And it's very similar to like, you know, when you go out and you have a salt shaker near the ocean, you know, humidity will cause salts to congeal and clump up. And people are storing the reagents for months by the ocean, you know, I mean, nice little sea breeze. So, you know, like just in terms of logistics and implementation, there are, as I tried to say, I mean, there's so many things we can talk about at length, but there's so many things that, you know, you can go down and something as simple as storage is important, and how you store things is important. It could really mess up the job because if you get a bunch of clumped up persulfate, your life just got real difficult.
Not to mention, it's not like a liquid storing it in the winter and just like things freeze.
Yeah.
And that's not necessarily a health and safety issue, but it is a major pain if you're like, we were planning to do all this work today and it's frozen.
Yeah. Well, and things get cold and then the viscosity and then trying to
Yeah.
handle, and then that's when you get the phase separation of some different things. In terms of how logistics commingled, ISCO to bio, I think is probably the easiest in terms of logistics. Because honestly, you don't always need to do too much. It depends on which one you're doing. The permanganate one, I'll also say if you go reductive bio after permanganate, you run the risk of mobilizing manganese, and that's not necessarily a good thing. With persulfate to bio, you have to pay attention to the sulfate and do sulfate reduction, but that's not necessarily a loss of your electrons. You just have to account for it and having enough electron donor. The reason why it's not necessarily a loss is the sulfide almost always precipitates out as iron sulfide, iron taken from the environment, and that's reactive in and of itself. And that iron sulfide is actually a reservoir, so you're almost storing the electrons for longer for it to react over a longer period of time. I've actually done that at a couple of sites, and it worked great.
Yeah.
And so you can go ISCO to bio. And like the one site, I mean, it was so close on its own about tipping because we knew that there was excess TPH, and it almost, it was almost about to tip, but the ORP wasn't quite low enough. It was like 0 when it needs to be about -100 to -200. We just added a little bit of organic electron donor. The site tipped, and then the entire aquifer went black. And that's when you knew that you were getting the iron sulfides. So in terms of logistics, and how different technologies, like I say, bio's going on all of the time, and sometimes you can just nudge it, and it will really take off, especially with sulfate reducers because they're ubiquitous.
So a factor that everybody always asks is cost, and I know it's all relative to the application, but in terms of the technologies themselves and comparison between them, your thoughts on cost between technologies that you.
Sure, yeah, I mean, certainly, bio can absolutely be used for some higher contaminant loading, but generally speaking, the sweet spot for bio is at often like sort of medium to lower level concentrations of your contamination. And part of the reason for that too is when we're doing these bioremediation programs, we're often, or at least ideally, either doing multiple rounds of applications or applications of a really long-lived electron donor. If we're talking about reductive dechlorination, as sort of long-lived an electron donor as possible, multiple years of longevity with whatever it is we're applying, which is really helpful when you're trying to get down to super low concentrations because it helps address all of that back diffusion and everything that's always going to be occurring. So the sort of like sweet spot from a cost effectiveness perspective for bioremediation tends to be that sort of medium to low level contamination. With that said, in conjunction with other products, like a 0-valent iron or something, it can also be used to tackle certain DNAPL and things like that. So it's not to say that that's the only place it can work, but that's often where sort of a sweet spot from a cost perspective is.
I mean, for like VOCs, thermal, we talked about like a minimum price point, right? With regards to the size of the project to get the equipment to the site. But, our large volume projects, they could run anywhere between like $150 to $300 per cubic yard. That rate increases when we're talking about small volumes. On the PFAS front, like those projects, nothing is rational right now. So those are crazy projects. Ideally, the technology, like an off-site disposal scenario. We are not quite there though yet with PFAS. We are trying really hard. A lot of our R&D is going into energy of making that high temperature application more energy efficient, because that's where we see the cost savings. But yeah, thermal's an expensive technology to be deployed, right? That's why there's not as many thermal projects out there in the world. Our company's done like 200 of them. There's probably like 600 of them here in the United States and then more abroad, but yeah, they're not as common as like bio or ISCO.
And that's too why you're generally speaking, PFAS aside, dealing usually with sites that have really high concentrations, right? Where, you get at least a better return on that investment in
Yeah.
terms of, you know, the cost you put in and the degree of contamination that you're actually removing.
Absolutely, yeah. There's always exceptions. Like I can think of this one project, actually that crazy highly angled one that I presented. That we win awards on the amount of dollars brought in on that project. It was crazy. It was 5 miles of, of boreholes installed at that site. The drilling budget alone was over a couple $1 million. But the thermal project was around 20 million for perspective. And we were targeting 300 pounds of mass. That's not rational either. That's not typical. That's an outlier project for sure.
So agree with everything they're saying, so I'm gonna go slightly different. Yeah, I have to be me. I actually would strongly encourage people to not look at the cost of the technology and the cost of the reagent in and of itself. I actually think the industry tends to just focus in a bio versus ISCO versus thermal. But when you actually look at the overall cost of remediation, site cradle to grave, from investigation to, like working with the regulators, with working with the public, with then coming up with the designs and everything like that, it actually becomes super negligible, super fast. The actual remedy. And so, I mean, at that point in time, when you can actually take a step back and look, as a site owner and what everything that went in. So I've actually seen a breakdown, a couple of people that tried to assess it. And this was for ISCO, okay, but ISCO, it costs money. But they had concluded that the remediation costs and this might have just been reagent, that the reagent costs, I'll just go with that, were like 2 to 3% of the overall project costs, all in, right? And it's just like, okay, so if you had doubled your reagent, you're at, say 5% of the overall cost. Now, when you sit there and with bio, maybe it would have been 4% of the overall cost. But is that, if ISCO, and bio maybe would have worked better, but hypothetically, if ISCO is going to be better overall, when you look at the whole picture, is it worth that extra 1%, of the overall costs? And even with my own group, and even with talking to, like clients and things like that. And when we're recommending things, we don't only sell oxidants, we have reductants and we have our iron products and we have metal stabilization, plugging left and right. But my point is we have to decide which of our own technologies we're going to put in front of people, right? That's a constant thing even within our group, because it's super easy to overwhelm people, right? And a lot of people are just like, well, our reductants are going to be 17,000 and ISCO's 25,000. So we're going to go with our reductants. And then sometimes I push back and I'm like, yeah, but you just chose a solid slurry that you're going to have to apply. That's going to be a more specialized thing. The crews are not going to be as ubiquitous and it's going to be more expensive. And, there are sometimes issues because, it can be more difficult than if you're going to inject just a pure liquid like you can get away with. And so even when you just look at the implementation costs and the reagent costs, you can start to see where, well, hey, this has to be paired with this, and the total cost of that are all of a sudden offsets, the additional cost of the reagent. When you start throwing in monitoring, right, some remedies, you got to monitor for 10 years afterwards, or 3 years or whatever. Monitoring is expensive. I mean, this is a benefit of having done it. I mean, when you throw in the report, when you throw in the monitoring, when you throw in the mobilization, I mean, it was like $15,000, $20,000 an event, and you're doing 3 of those a year, you're talking about real, 3 or 4 of those a year. If you're doing quarterly monitoring, that's real money. And that money, if it was put into the remedial costs, might have offset and allowed you to go to a technology that maybe you're done and out in 3 years, not 10. So it's a total cost from my perspective.
Yeah, that's a really good point. And sort of like looking at it holistically, like cost is often a primary driver, but it's obviously not the only thing to consider, right? What your overall timeline is on any other drivers. Are you getting pressure from, your regulator or your next door neighbor, or you may be like getting threatened of potentially getting sued? All these things that are like these external factors that are going to potentially also influence what the appropriate next step is beyond just the dollars and cents right now.
Yeah, and just one other little bit, like soil mixing versus injection. You can get the additional mass in soil mixing. There are jobs that are now going soil mixing just because it would have been 3 injection events versus 1 soil mixing event. And that soil mixing is now cheaper. But the industry is like, oh, soil mixing is expensive. Well, if it's a contaminated site and you're saving yourself multiple applications, no, it's not. It's actually cheaper. So. Totally.
Yeah, we encountered a lot of success using soil mixing on site, but one oversight that we can, Fred, you probably remember this one, up in, Conway.
Yep.
Mixed,
They didn't do binder.
a clay silt, and there was someone with adding the reagent, it added so much moisture to the soil that it made a soup out of it, so we couldn't stabilize. We had, then there was a whole nother part of the project to stabilize this pool of mud. That was,
Yeah, that's actually the picture in one of my presentations, that side.
Oh, yeah.
Yeah, the one with the billing and its tool is right over it.
yeah.
That side. And, and so nowadays, that should have gone ISCO ISS, but there's some politics behind that side that I'll talk about.
In your upcoming webinar.
And my, next Wednesday.
Anything from the audience?
Yeah.
I'll jump into this a little bit. I think Brant's already touched on the idea, but we've got a lot of regulators here. And is there something that you just, each of you, and maybe Brant's already started it off, which the regulators would realize? And cost and the whole total cost, I'm sure is something that some of us have bumped into in our considerations of our role. But what other things might be good for those in the regulator seat to be aware of that maybe we aren't aware of, as our capacity is not so expansive that we have all knowledge, although we might like to think.
Yeah, it's a great question. And honestly, we sort of touched on this yesterday, so I'll echo a little bit of that conversation, but sometimes we're dealing with, property owners, responsible parties, whatever the case may be, that, their objective is, I want a line item in each annual year's budget for environmental, right? That's gonna be their reports and, monitoring and maybe a little bit of treatment here or there. And they just wanna keep that number as low as possible. Versus all of us, the rest of us in this room, right? We're trying to do things in a cost-effective way always, but we're maybe saying like, spend a little money now, and in the long run, it should really pay off, right? Versus there may be looking at things from a different perspective, like an annual budget versus a total cost, which gets a little bit to what Brant was getting at too. So I don't think that's specific to the regulatory community. It's really just something like all of us as practitioners maybe don't think of as much being at the forefront versus the people ultimately footing the bill for a lot of this stuff. That's something that's important to them often, is a different type of financial consideration.
And some of them look at the big project life cycle picture, right? And they're very attuned to like wanting to do remediation and wanting to clean up, but some of them are very focused on like the calendar year, and they can't even manage their budgets beyond that calendar year. So in that scenario, it does create a highly motivated client to not want to do remediation. Unfortunately, it's nothing that you can control, or maybe you can with enforcement, right?
Well, it's like if you make the financial disincentive, right?
Yeah.
Lack of doing something much more expensive, then that changes the cost benefit analysis of what makes sense to do right now.
We do. I get a lot of calls from state regulators, we've been trying to do this for the last 10 years. Can you give me quick pricing for thermal? Because we don't have like
$1 million.
Yeah, I don't know what else we're gonna do at this point. And it's like, sure, that's gonna be 1.3 million or whatever the price point is. And it's like, oh no, we have $100,000 left in the funds. Like, You call us at the beginning. Yeah, that might be, for some of the state funded projects, one way to consider thermal upfront. Not that you're getting a lot of like brand new projects.
I think that's part of the interesting point that we're at though, that I see on projects that when some of this all first started, back in the day, when sites were starting to be cleaned up, there was this vision that fire remediation or, monitoring natural remediation, gonna take care of everything, right?
Yeah.
Now we see these sites that are like, nothing has changed in 10 years,
Yeah.
25 years later, we're like at this point. And my line that I like to say to people is, do you want to continue to monitor this in perpetuity? Like, if you say like they only see this year or they can't see 10, but when you drop that line, like literally at this point, you're gonna be spending $10,000 a year to monitor this site in perpetuity. How about we go back to the drawing board with some of these new technologies and take a second look at this, and maybe we can knock this down in 10 years, because you won't be monitoring it instead of in perpetuity. I always love the, like, when you drop that in, I'm like, we're not gonna get anywhere at this point. Like,
Yeah.
that line really gets to people, they're like, forever. It's like, we've done it for 25 years, it hasn't moved the needle.
Yeah.
So like if somebody doesn't interrupt me, I'm gonna talk in perpetuity. You guys saw, it's possible. Got Kane on that one. In answer to your question, and first, regulators wear many hats, and I do want to say overall, the system in general works, right? I think one of the things that I would say, and it's actually something we talked a little bit more about yesterday on the Q&A, and so I'm going to bring it up, but it's the concept of flexibility. And this is not every site, but I absolutely come across sites where like they have a rod and they can't change anything. I mean, it's just like, it is written in stone, and it basically, there's almost a fundamental assumption that everything is known about that site. Yet, when you talk to people like us that are going out there and applying things at sites, or supporting people that are applying things at sites, things change. One of the quotes that I like is, every time you go out to the site, you learn something new. I mean, anytime you look at it, you learn something new. And, again, one of the things that, you've heard, we were just talking about, different technologies, how they can be combined. But the other word that I will get out there is pivot, okay? We actually, and you heard the insanity reference, when you hit that point of diminishing returns, you'd like to pivot to something else. And I have absolutely many times, and it's not all, sometimes people are very flexible, or rods are flexible or something like that. You are able to pivot. Sometimes people are like, sorry, I know that you're trying to save me money. I know you're trying to do something better. We can't do anything. I encourage flexibility though, to the point, in like designs, injection concentrations. I sometimes when people are trying to max out an injection concentration, I just throw it back at them. This is how much I'm into flexibility. And I'm like, okay, so what are you going to do when it goes sideways? What are you going to do if all of a sudden you're trying to get all this mass in the ground and you're already at a max out concentration and you can't get it all in the ground? And they're just like, I don't know. And I'm like, but if you inject at, say 80% of theoretical solubility instead of 100%, you can increase your injection concentration. And so having flexibility when going out there and working in the subsurface and trying to figure out how to adapt as the site teaches you something about it, and how to adapt as you get to midpoints of insanity, diminishing returns, and how to pivot. Having flexibility is crucial in having a successful remediation event.
And going off of that a little bit,
Sure.
when you are hitting those diminishing returns, or you've been very successful and you're just hitting something where it's just about recalcitrant, not cleaning up anymore. We have a lot of sites that are open because we have, naphthalene trimethylbenzene at these very, very, very low concentrations, and we just can't get them below standard. Do you have advice for targeting those sites to like get them just over the finish line?
I mean, first of all, give me a call. Because it does get into specifics,
Yes.
but generally speaking, when you're doing something like that, what you just told me is that you likely had a strategy that went after less permeable or lower KOC, higher solubility contaminants.
Yeah.
You had probably and again, thinking in terms of time, you had a shorter term technology that went out there, cleaned it up. Those compounds that you just rattled off, lower solubility, higher KOC. Okay, so what goes after that? And, you know, this is one of the slides that I tried to have and tried to talk about. Sometimes you try to match the reagent with the time frame. And, you know, if that's the case, and again, I'd have to know specifics about the site, you would need to have a reagent that's going to sit there and be active while that slowly desorbs. Okay, so it's, you know, the diminishing returns, it could have been a, you know, aerobic barge system or something like that. And, you know, you just didn't maintain the, you know, some people would just say, just keep running the system longer. But, you know, sometimes it helps to pivot to something that's going to persist for years. Sometimes also when you start talking PPB, what's actually going on is you're dealing with back diffusion out of low perm units. And if that's the instance, that can get kind of difficult because you can back diffuse out of clay for centuries. There was a study done at Sikorsky in Connecticut, and you know they pretty much evaluated that it was going to be 500 years. So what we recommend for people, and this is injection strategies, right? You've cleaned up your preferential pathways. You've got to get into the low perm unit where that stuff resides, and you got to create those fractures and let things diffuse out of the fracture into that low perm unit. So it depends a little bit about the mechanism, so it's site specific. But when you are talking about, you know, what you're describing the general scenario, those two, at least in my experience, that's a lot of them, you know.
You heat it up?
We're all plugging now.
I was just gonna say, like, give me a call, we can talk about how soil activated carbon can be great here. No, I mean, it sort of what Brent was saying, like, pivot, right? Like, clearly if what you're doing hasn't worked, reach out to other folks like us, and we'll give you our ideas about what a good next step could be.
Yeah, and this is a plug, but this is a plug for everybody, okay? A lot of different groups have internal technical resources. And just be aware that we all exist. Others within our groups exist. And that you can reach out and ask questions and go through these sites. It's regulators, consultants, contractors. I mean, you know, I've worked with these guys, you know, I've known a couple of people for a long time, a couple of people I'm just meeting on this event, but you can tell that the general philosophy is we understand all the different, you know, stakeholders that exist out there. And by, you know, getting everybody aware and making, you know, the tide rise, that's how, you know, you create a long-term successful industry.
Do you have a question?
I did, but it's after 4 and I don't want people looking at me.
That's very.
A round of applause for the great.